Hello class, in this video I'll be using the fundamental theorem of calculus to evaluate a definite integral and then show you what the value of the definite integral represents. Let's begin. So at the top I have the fundamental theorem of calculus that you can reference, and we want to find the value of the definite integral from -2 to 3 of x squared dx. And the first thing we want to ask ourselves is f of x continuous? And the answer to that question is yes. F of x is a polynomial. Therefore, it is continuous on its entire domain of all real numbers. All right, so now that we established that x squared is continuous, we can now apply the fundamental theorem of calculus. All right, so we already labeled x squared lowercase f of x. The antiderivative of x squared is x cubed divided by 3. And we're going to evaluate that from -2 to 3. So the antiderivative, I'm going to label capital F of x. So this definite integral is equal to capital F of 3 minus the capital F of -2. So now all that's left is to evaluate the antiderivative at 3 and at 2. Or sorry, -2. I'm going to leave that expression as 27/3. It will be easier to subtract. So capital F of 3 minus capital F of -2 is equal to 27/3 minus a -8/3, which is 35/3. So the definite integral from -2 to 3 of x squared dx is equal to 35/3. And what does this number represent? Well, over here, I have sketched the function f of x is equal to x squared. And the function is above the x-axis for the entire domain. So I'm going to highlight the area between the curve and the x-axis in green to represent positive area. So this area in green has a value of 35/3. There's no area in red to subtract, so the area in red plus the area in green is 35/3. And that's what the value of the definite integral represents.